Hi guys, I'm Rahul Maraj and I will be presenting online mathematics and science. You are watching my Introduction to Algebra lecture series, and in this video we'll be converting recurring decimals into fractions. So let's get started. But before we get started, let us recall our real numbers. If you have not watched the video that I uploaded about a month ago, now is your chance to do so. So we said that real numbers consist of rational and irrational numbers, and whole numbers, natural numbers, and integers, those are examples of rational numbers. Rational numbers can be written as fractions of the form n over m, where the denominator m is anything other than 0. But irrational numbers, they cannot be written as fractions. We also said in our video that, let's get to the part where yes, so on that part of my presentation, we want to know why we said that recurring decimals are real numbers. And the answer is, it's because they can be written as fractions. But how can we write them as fractions? This is what this lecture video is about. So let us start by converting a decimal such as 0.3 that recurs as 1 over 3. So we do that by letting y be equal to 0.33333 going onwards. We will call that equation 1. Since we have one digit repeating, we can multiply both sides of equation 1 by 10, which will give us 10y is equal to 3.33333, and this is equation 2. We then take our equation 1 and we subtract it from equation 2 to get 9y is equal to 3. And if you divide both sides by 9, you will get y on its own, and y is equal to 3 over 9, which is 1 over 3, thus proving that 0.3333 recurring is 1 over 3. Convert 0.454545 into a fraction. So we let x is equal to x or y is equal to 0.45454545, and we call it equation 1. Notice that only two digits are repeating. Therefore, we can multiply both sides of equation 1 by 100 for the decimal to shift to 2 places to the right. So we have 100y is equal to 45.454545 recurring, and we will call this equation 2. Now, what we do next is we subtract equation 1 from equation 2, and if we do this, we will have 99y is equal to 45, y is equal to 45 over 99, which is 5 over 11. Let us convert the decimal 0.102102102 as a fraction. Okay, so we let y be equal to 0.102102102 going onwards, and what we do is we call this equation 1. Since we have 3 repeating digits, we can multiply both sides of equation 1 by 1,000. And if we do that, we will have 1,000y is equal to 102.102.102.102, which we can call equation number 2. Then we are going to subtract equation 1 from equation 2. And if we do that, we will have 999y equal to 102. We can divide both sides by 999, and this will leave us with y is equal to 102 divided by 999, which is 34 divided by 333. Let's do this exercise where we convert the following decimals into fractions. So here we have A, B, C, D, and E. I want you to pause the video and convert those decimals into fractions. Okay, so For A, we have 0.11111. What we do is our normal routine where we let y or x be equal to 0.11111, and we call that equation 1. Then we multiply both sides of equation 1 by 10 because we have only one that's repeating. It's a single digit. And that gives us 10 is equal to 1.111 recurring. We call that equation 2. We take our equation 2 minus our equation 1, and this will give us 9x is equal to 1. And if we divide both sides by 9, we will have x on its own as 1 over 9. Let's look at B now. B is 0.2828282828. So we can let our x be equal to 0.28282828, which we can call equation 1. Okay, we can multiply both sides of our equation 1 by 100, since we have two digits that are repeating, 2 and 8 in a pattern. This gives us 100x is equal to 28.28282828, which is equation 2. We then take our equation 2 and minus our equation 1, and this gives us 99x is equal to 28. And if we divide both sides by 99, we are going to get 28 over 99 being x. So that's how you convert recurring decimals into fraction. Let's look at our third one, 1.11111. What we can do, note we don't have a 0 point. It's now a 1.111. So what we do here is we can write our 1.111 as 1 plus 0.11111. But hang on, we already converted 0.111 as a fraction in question A, because we found that it was 1 over 9. So we can add 1 to 1 over 9, and that will give us 10 over 9. In D, we have 3.654 recurring, so we can write it as 3 plus 0.654654 recurring. So we're going to let this decimal, now we want to find what this decimal 0.654654 is. So what we do is we let our x be 0.654654. We call it equation 1. Since we have three digits repeating, we multiply both sides of our equation 1 by 1,000. And this will give us 1,000x is equal to 654.654654 recurring. We can call that equation 2. And then we take our equation 2 minus our equation 1. This gives us 999x is equal to 654. And if we divide both sides by 999, we will get x is equal to 654 divided by 999 as 218 over 333. Therefore, we can write 3 as 999 divided by 333 in order to make the denominators the same. And we can add our fraction, 218 over 333. And since the denominator is the same, we can add the numerator, and this gives us 1,217 over 333. In E, we can write 9.8764 recurring as 9 plus 0.8764 recurring. We know how to convert the 0.8764 recurring as a fraction, so we let our x be equal to 0.8764, and we call that equation 1. Since we have 4 digits repeating, what we're going to do is we're going to multiply both sides by 10,000. And if we do that, we'll have 10,000x is equal to 8,764.87648764, which we can call equation 2. Sorry for the typo. I hope you're not colorblind. So we take our equation 2 minus our equation 1, and this will give us 9,999. X is equal to 8,764. And if we divide both sides by 9,999, we will get 8,764 over 9,999. We can add it to 9, which is 89,991 divided by 9,999 in order for the denominators to be the same. And then we add our numerators to get 98,755 divided by 9,999. Okay, that's the end of my presentation. Thank you for watching. Feel free to email me on raomiraj523@gmail.com or WhatsApp me on +2773 483 5887. I look forward to hearing from you. Thank you so much for your time. God bless you, and I wish you luck and the best in your future. Amen.